Okay, now, again, for those of you who weren't here because you were practicing for National Day, is that what they call it? National Day?
We weren't doing that. Yeah,
is that what they call it?
We had, yes.
National Day, okay. We are about to celebrate, what are we celebrating? Independence Day, National Day, what do you call it?
National Day.
And it's 43, right?
Yes.
43 years old, okay? I am older than the country. That's a little weird, okay. So anyway, quizzes will be like this on nomenclature. They will be like this. I give you a chemical name, and you give me the chemical formula. Or I give you a chemical formula, you give me the chemical name. So what we're going to do right now is we're going to do acids. There's two types of acids in terms of nomenclature, okay, and how to name them. There are binary acids. There's binary acids. A binary acid means how many elements? Two, okay? Now, first of all, with acids, okay? Yes? But for a binary acid, you're going to have a single element anion. A single element anion for a binary acid. Do you understand what I mean by that? Yes?
Yes.
For instance, we know, based on binary nomenclature, very simple nomenclature that many of you may already know. I know that Mr. Nair went over it.
Yes.
Yes, you have, for instance, we have, pick an element on the right side of the table. Pick a non-metal, any non-metal.
Boron.
Okay, no, I don't want to pick boron.
Silicon.
Sulfate.
Chlorine.
All right, fine. Pick some.
Hydrogen.
Something between 43.
All right, fine. You've made your point. Okay, fine. So let's pick, actually there's not a lot to pick from actually. It's not just a non-metal, it's like 17. May I pick one?
Yes.
Yes.
All right, the chloride ion. Remember, an anion, an elemental anion, is named by using the name of the element with the suffix IDE. So you use the name of the element chlorine as the root, and then you put the suffix IDE on the end. So chlorine becomes chloride, okay? Now, so if chlorine's -1 and hydrogen is +1, and hydrogen is always the cation, what would the formula be for a acid made of hydrogen and chlorine? HCl, okay? Now, the question is, how do we name them? I'm just going to write a bunch on the board. And writing the formula for binary acids is actually very simple, isn't it? So, HF, HBr, HI, H2S, H3N, H3P. Okay, yes? Yes? Binary acids. Is anybody mystified as to how I would get those formulas? Okay, so that's -1, +1. Phosphorus, -3, +1. Right? What did I do? What's this? 8 + 1 - 1, right? -3, right? +1 - 2, right? +1 - 1, +1 - 1, +1 - 1, right? Easy? How to get those formulas? Now, the way you name them is this. This is the way you name them. You say, I don't know, if I ever fall off the boat in the middle of that river, what am I going to do? I have no right arm.
You have a life vest.
Just wave, because just wave goodbye, okay? And throw some flower petals. Make sure you bring flower petals with you, okay? Okay, Aquaman will save me? Excellent, okay. I always wanted to meet a Nepalese Aquaman. Excellent, I can't wait, okay. Hydro is the prefix. You put the root, and then ic. That's it. Easy? Understood? Red's looking at me like I said something like really weird. Okay.
Sort of like hydrochloric.
Yeah. Hydrochloric.
Yeah.
There's an extra syllable here. Hydrophosphoric. There's that extra syllable. I know, you can just get used to it. Hydronitric. Hydrofluoric. Hydrobromic. Hydrosulfuric. Hydroiodic. Easy? That's it. Is that easy? Yes.
Which one's the most dangerous one?
Hydrochloric acid.
Of the binary acids,
Yeah.
I would personally, my least favorite one to be around would probably be hydrochloric. I mean, I wouldn't go anywhere near any of the acids, but the halogen acids, the halogen binary acids, this you can buy in the store. I mean, you know what this is called in the store? You go, if you do concrete work, you use this. It's called muriatic acid. That's the old classical name for it. Muriatic acid. If you go into a store, because you're doing concrete work, go into Home Depot, you can buy muriatic acid. And it'll burn you severely. Okay? But the one that you see in labs all the time, the one that I like least of all, the common, widely used acid, probably the most widely used acid in industry, don't quote me, sulfuric acid, scares the bejesus out of me. Sulfuric acid, just the worst. Okay, so is that easy? That's not hard, is it? Is that hard? Is that easy? That's it. Now, the other kind is ternary acids. Okay? Ternary acids, there are far more ternary acids than binary acids. Okay? This is how you do it. Is H and then a H and a polyatomic ion, -1 anion. Okay? Right? I'll get rid of this because it could be more than just one charge, okay? H plus and then a polyatomic ion, anion. Okay? Yes? Pick a polyatomic ion that you're familiar with, anything.
A what?
Polyatomic ion.
What?
Has anybody ever heard of sulfate?
Yes.
Yeah, okay. So sulfate, -2 charge. What's the formula for the acid, the ternary means 3, right?
Yes.
1, 2, 3, yeah. Ternary, what would it be? Very good. H2SO4. Yes? Easy? Now how do you name them? Okay? You say this. You say nope, there's no prefix. Okay? No prefix. Root. Right? And now you got to look at the prefix of the suffix of the polyatomic ion. 8 becomes ik, and ite becomes us. So what's the name of that? Sulfate. No, there's no prefix. Sulfuric. Sulfuric. You have that extra syllable. With sulfur and phosphorus, you have that extra syllable. Okay? You got to get used to that. Just get used to it. So sulfuric. Okay?
What's an example of ITE that changes to OUS?
ITE goes to OUS. I'm going to show you something very quickly, okay? I'm going to show you something that's on the videos from yesterday, and I'll show you this, and then we'll be done, okay, for the day. You ready?
Yeah.
Okay. If I want to if I want to write down or if I want to remember like a zillion polyatomic ions, all you have to do is know 3 or 4, and then the rest are easy. Okay? For instance, if I say, this is the number of oxygens. No, that's not right. Yeah. Okay? And then this is -1, -1, -1, -1, -2, -2, -3. Okay? You ready? So, I know, this is what I know. I'll do this the way I do it. Okay? I know that's chlorates. I know ClO3. I know that one. Okay? I know bromate. I know iodate. I know carbonate. I know sulfate. I know phosphate. Right? Yes? You get that? Okay. Now you fill it in. Now fill in the chart. Everybody, come on, fill in the chart. So I'll put in the rest of them. So ClO, ClO2, ClO4. You can only have 4 in a group. BrO4, BrO2, BrO, IO, IO2, IO4, O4. No, that's not right. I can't do that. So I can go. What am I doing? So you got it out of place, see? You got this out of place.
I think it's self-recorded.
What is it?
I think it's self-recorded.
Yeah.
Is off the.
It's in low battery.
What is it?
Low battery.
That's okay. It'll still film. Okay? Is that good? You get it? You have no idea what I just did, but that's okay. We'll do it. You ready? Let me get this. Where's a... Okay, you ready? Okay. All right, this is how you name these. Okay, you ready?
Yes.
Okay. You ready? Let's see. Blue. Where's blue? I don't have blue. I'll use black. Okay. Over here you say hypoite. Hypoite. Ite. 8. 8. Her. Okay, you ready? You ready? Okay. Okay. You have 4 minutes. I can do this. You ready? Okay. This is chlorate, bromate, iodate, carbonate, sulfate, phosphate, right?
Yes.
Yes? Okay. This is hypochlorite, chlorite, chlorate, perchlorate. This is hypobromite, bromite, bromate, perbromate. This is hypoiodate, iodite, periodate. This is hypocarbonite. This is carbonite. This is carbonate. This is percarbonate. This is This is hyposulfite, sulfite, sulfate, persulfate. Some of these don't exist, but they're consistent with the nomenclature. This is hypophosphite, phosphite, phosphate, perphosphate. You get it? You get it or not? Now, all of these can become acids, right? This is going to be, by the way, this is this is bleach, sodium hypochlorite, okay? This is bleach, so this becomes hypochlorous acid. Ite becomes us. This is chlorous acid. This is chloric acid. This is perchloric acid, right? Hypobromite. Ite becomes us. This becomes hypobromous, bromic, perbromic. This is hypoiodous, iotic, periodic. This is, I know that's carbonic, this is hypocarbonous, carbonic, percarbonic. This is hyposulfurite. This is, hyposulfurous, sulfuric, persulfuric. You get it?
Yes.
That's it. Nothing else. Now there are some exceptions. That's just because there's a clash between the classical and the IUPAC. If it's if the polyatomic ion is "-ide", it's "-ic". Okay, for instance, cyanate, right? Cyanate. Sorry. Yeah, cyanate ion, right? Cyanide, sorry. Cyanide. Cyanate's different. All right? What did I say?
Cyanide.
Cyanide. So it would be
Yes.
cyanic acid, right? It used to be a lot used in capital punishment in the United States. They would say sulfuric acid plus potassium cyanide. How to teach chemistry in an uplifting manner. Okay. Sulfuric acid plus potassium cyanide yields potassium sulfate plus cyanic acid. This is a gas that evolves, fills the chamber, and they choke on cyanide. Yes? Get it? It's gross, I know, it's foul. Yes? So anyway, so that's an exception. The polyatomic ion cyanide becomes cyanic acid. Yeah. So the "-ide" becomes "-ic". Now there's another exception before we quit. One more exception. This is a polyatomic ion, and you'll see the connection when we do 19 H plus OH. That doesn't become an acid. That becomes water.
Yes.
And there is actually a connection in chemistry with that, okay? All right, have a good night, guys. Study your nomenclature as well as chapter 6. You heard it here first, if I'm really rotten, I may give you a quiz after your test. No, I know, I can't even, I can't even say that with a straight face, okay.